Hey everyone, welcome back to the shop. We are in the new shop this week, and you can probably see that there's a little bit of change that's happened in here. We're going to talk about that. I want to give you guys some updates on things that's been going on around here, and things that we're going to be looking forward to in the new year 2025. I am also continuing to work on the USA made Hardtail Vise. Last week we were in the home shop using the shaper, working on the main vise body. And in that video, I had mentioned that I'm wanting to replace these guys right here. These are the factory clamp bolts that go into the Hardtail vise. And I'm working on my prototype replacements for these right here. And that's what I've been working on the past day or so. And I'm trying to get to a point where I feel comfortable with the program and making a good finished part there before I move on to the actual finished product, which is what I want to get to. We're not going to be making the finished part in this video, but what I would like to share with you is the work that I've put into designing and machining the prototypes up to this point right there. So I wanted to utilize my Miltronics CNC machines to make these for a couple different reasons. Every time I go into a part or a project like this, it's continuing my training with CAD and CAM, continuing my understanding, and each time I go in there and I practice on Fusion 360, I learn a little bit more. And not only do I learn a little bit more, I remember things a little bit more each time. You know, it's such a powerful software that there's so many things you can do with it. It's really hard to kind of go in there and just know all the capabilities of it. That's why I like working with Kevin over mechanicaladvantage.com. As I've said before, I get with Kevin nearly every week for at least 1 or 2 sessions, and we go over it, and he helps me even with simple projects like this, because even a simple thing that you want to design, turn to thread something, can be a little challenging if you're not used to CAD and CAM. So I don't use it every single day, so I don't have as much practice as guys that are running CNC shops or doing CNC work every single day for their job. It's more of a learning experience for me so that I can continue getting better and more efficient at it. So we're going to jump back on this and talk a little bit more about these. But what I want to do first also is kind of give you some updates on what's happened with our Flex CNC that was in the shop, and even talk about the Miltronics there as well. So back a couple years ago, I think it's been about 2.5 years now. I don't remember exactly when it was, but about 2.5 years ago, so when we started putting all the modern CNC machines into the shop here, and we put the G Series Flex CNC in the shop. I had mentioned to you then when the machine came in that I was working with Flex CNC. I've been partnered with them for several years. I enjoy working with those guys, just an awesome group of individuals there, and I just love working with them. And they wanted to put one of their machines in the shop here for me to use however I want to learn CNC. They wanted to be part of this journey of me wanting to try to improve my skill set, not just do manual machining, but step into the CNC side as well and learn how to operate those machines and be able to provide that service to my work and my customers as well. That's what this journey has been about. Not replacing manual machines, but learning how to use all of them in my shop, for my advantage there of getting all this work done. So, machine was put in a couple years ago. We've had a lot of fun with it. We've been using it. We've done some really great projects with it. And that machine has always belonged to Flex CNC. That's always been there. It's just for me to use. I got a call back in December that they had received an order or request for an order from a customer out in California. They wanted to buy 5 of those G Series Flex. And so they called me and said, we'd really like to go ahead and cycle that machine out, get it sold, get it to a new customer, and get it out of the shop there. So they wanted to make sure that was good. And I said, there's no problem there. I mean, if you guys, that's what you want to do, let's do it. So they decided to go ahead and sell that machine as part of that package. So somebody got a good deal on it. I'm sure they gave them a discount. It was a fairly low hour machine. And so it all happened pretty quickly, within less than a month. So Flex came down here, they decommissioned it. They hired some riggers to come in here, get it out, load it up, and it is now to its new owner in California. I have no idea where it went. They just told me that it went to California. So that's where the Flex is at. And sounds like it's going to be in a nice manufacturing facility making lots of big parts. So that's where we're at with the Flex CNC. Well, until the next Flex CNC, we had a lot of fun with this one. See you later. But the cool thing about that is that we're going to be replacing the Flex CNC with another machine there as well. We are going to be putting another Flex in the shop, only this time instead of the 20-foot long bed, we're going to be going with a 10-foot bed. So that's going to kind of clear up some of my floor space in here, which is a nice bonus, you know, because I'm limited on my shop space, as you guys can see, and the Flex is a big massive machine, and it's really nice having that 20-foot bed. If you've got some work that you want to work on full length materials, it's perfect for that. But I only had to use that a couple of times for different jobs, over 10 feet. So I'm not really concerned about that. So we are going to be going with the 4-foot by 10-foot with the replacement machine. It's probably going to be sitting about in the same place as the old machine was. I requested the smaller coolant tank so that it's going to be taking up a little less room down here on this end. And that's going to allow me to have more space back there where the forklift and all the other stuff is. I'll have space back there so I can hopefully in the future add another machine. Now what that machine is, I don't know yet. I haven't decided, but I wanted to have the possibility of adding another machine to the shop, whether it be another mill or whatever. And with the Flex in here that was in here, I just didn't have any more space except for maybe something small. So that's what I wanted to share about the Flex CNC. It's probably going to be, I would say, mid late summer at the earliest that we're going to be getting that machine. They still have to build it, so it takes a little while. But I am excited about that, and I'll be sure to share that journey with you whenever the machine gets here and gets it hooked up. But what I'm hoping to get to eventually is some manufacturing. I have some ideas for some parts that I would like to make. Some small things that I can make utilizing my equipment here, my CNC machines, something that I can maybe sell to you guys, my viewers, my followers, or anybody that might be interested in something. I've had a lot of requests over the years. People, would like something that I make, and that's what I would like to do. I've got a few things in my mind, some things that I would like to build and maybe even manufacture. And that's why I was saying that I like the idea of having a little more space back here, so that if I need to, I've got a little room that I can add another machine if it comes to that. So I'm excited about that. I haven't started on any of those ideas yet. They've been floating around in my mind for a long time. A couple of years now, I've had some ideas for some products that I would like to make, and I just haven't started on them yet, but I'm hoping to very soon. If I can just get through some of the other projects, I have jobs that continue to come through the door that I have to work on and get done, and I'm just going to have to get started on it. That's all I can say. I just got to start and start making some prototypes and refining it into a nice, fun part that I think people might want to buy and purchase. So that's one way that I want to start utilizing my shop space here, is not just for job shop work, not just for something that comes in the door that I got to fix, but actually doing some light manufacturing, some small batch parts that I can sell to you guys out there that are viewers of the channel and followers of the pages. So I think I'll grab the camera, walk around a little bit. I have a little bit more that I would like to discuss about the Miltronics. We have an update with those as well. I have a couple jobs here that we're going to be starting on this week. Some really good stuff that I think you guys will enjoy watching. So I'll show you those, a little teaser, so you can see some more projects that's coming up on the channel. And then we'll get started on our prototype for our Hardtail Vise clamping bolt right there, okay? All right, so I wanted to show you some upcoming work. We've got this hydraulic cylinder right here in the shop. Goes on a Mahindra tractor. It's for an outrigger, and a couple things wrong with it there. You have a rod gland that is just completely chewed up. The threads are galled, coming out. So we're going to be replacing this, and I'm going to be machining this from ductile iron instead of the aluminum. So we have some ductile for that, and I'm still waiting on the seals to come in. The material shipped, but they had to order one of the seals, so it should be here in another day or two. But we'll once I have the rod gland machined and everything ready to go, we'll go ahead and build it and put it back together. The barrel here, first thing we're going to have to do is a lot of that aluminum galled inside those threads there, so we need to set this up in the lathe and actually chase those threads to clean them up to make sure that our new gland is going to screw into that barrel properly. All right, so this is a job that's coming up right there. I did want to mention to you guys, because this is helpful, CRC Industries, luckily for me, they're local. They're over in Robertsdale, Alabama, which is less than an hour drive. They have all the materials for hydraulic cylinders. It doesn't matter if you need aluminum or ductile for pistons and rod glands. Chrome plated rod, you have the regular chrome rod, you have the induction hard rod you can get. They have all the honed ID tubing over there for pretty much any size hydraulic cylinder you can imagine. So they have all the material over there, including all of the soft parts that you need, soft seals, everything. All right. They also sell drops. They have a drop shelf. These are a couple pieces that I went ahead and added to the order because this is some really handy stuff to have around the shop. I use this a lot for projects and making parts, and even customer parts there as well. So if you guys are in need of like some material, this is 1045 steel. You can check with them because they have drops of all the different size rods that they sell. And you can usually get it for a little bit of a discount versus the regular cost of a full length rod there. So good way to just add some material if you need to in the shop. This is really good stuff to have. So they had these two on the shelf, so I just added that to the order. So I just wanted to mention that. Really good folks over there at CRC Distribution. Boy, it really is nice seeing the shop kind of opened up and have a little bit of breathing room in here. It's I haven't seen it this open since we first moved in, but I am excited too about getting our new machines in here and having a little more space back there as well. I need to do some organizing in here, and that's something I'm going to be working on soon, trying to get just a little bit of organizing done and things kind of laid out a little bit better. All right, so this is another job that I just got in the shop right here. This is a piece of heavy wall DOM tubing. Belongs to a local customer that they do paper products. They cut paper like butcher paper. If you ever bought butcher paper, they do things like that, but I mean for all different kinds of industries. So that's what they do, is they cut paper. This is going to be a mandrel for one of those paper cutting machines, and what we've got to do is turn it from end to end. There's a specific diameter that it needs to be, and then each end is going to be turned and threaded for one of those bearing nuts, and the ends are counterbored for the bearing there as well. They did provide a print for me to go on, so I do have the dimensions there on an actual drawing provided by them. So this is going to be an upcoming project very soon. We're probably going to get started on this next week, and we're going to be using the American pacemaker to get this job done. So I figured you guys are going to like that. Really nice manual lathe job right there. All right, so we're going to move around here to the Miltronics. I have a little update that I would like to discuss with you on these guys as well. So about 3 years ago, when we first installed the Miltronics, whenever we put these in, I mentioned in that video as well that I partnered up with Miltronics. They wanted to provide these machines. They wanted to put these machines in the shop to help me and help be a part of this journey of me learning CNC and modern manufacturing. And that's exactly what they did. And they have been great to work with. I mean, just a great group of individuals up there at Miltronics, and I have absolutely enjoyed my partnership with them. We are continuing that partnership, and what we're going to be doing is we're going to replace the TRM 3016. We're going to be replacing it with a VM 3018. So we're going to be going from a tool room mill to a full-on production mill, and I'm really excited about that. I have really enjoyed learning how to operate this mill right here, and this is an excellent machine for any machine shop out there, especially job shops like myself. If you guys are running manual machines, manual mills, and you're looking to step into something that is fully enclosed, that has full CNC capabilities, this is an excellent mill. The TRM, the tool room mill. 30x16 is your travel there. But yeah, we're going to be replacing this with the 3018, and that's going to allow me to have faster spindle speeds. We're going to have the side mount tool chains. I believe it holds 24 tools versus the 16 umbrella style. And because of it being a full-on production machine, we'll have fast tool changes. It's got the swing arm tool change in there. I believe a 10,000 RPM spindle. It's going to have the through spindle coolant equipped with it. It will have the Renishaw probe, and it's going to have an auger on it as well. This one was not equipped with an auger, so I have to get in there and, you know, shovel all this out by hand. But the new one will have the chip auger, what I'm excited about, so we can, you know, turn that on to get the chips out of it. The other cool thing about the new machine is that, so they have updated their controller. They just launched it last year at the IMTS show. Their new controller is called the Inspire, and so the new machine is going to be equipped with the new software, the new controller on there. So it's supposed to have a lot of benefits, updates, supposed to provide even better parts, you know, better finishes and more options on the controller and things like that. So this is probably going to be later in the year as well, because they too have to build the machine. It's not ready yet. We just kind of talked about this recently and made the deal on it and decided to go forward with it. So it could be March, April, May. I'm not really sure yet, but I'll let you guys know whenever that happens. And so this one is going to be going away, by the way. So we're going to disconnect this one, move it out of the way. That's another, it happened at a good time that the Flex is gone, because it's just going to make our job easier. But we're going to move this one over. We'll put the VM 3018 directly in its place right here. And then Miltronics is going to be taking this guy back. And what they told me is they're going to use this in one of their showrooms as a demo machine. So I am excited about that, and I'm looking forward to having the updated machining center in here to use, and that hopefully is going to help benefit me whenever I start working on these production parts, these ideas that I have to make something for you guys out there, make a product that I can sell to you guys out there. That's something that I'm really excited about. All right, so I'm ready to go ahead and jump into this project and show you where I'm at. I wanted to give y'all a demo of what I've been working on, getting this program and this part proven, and I think I have a good part now. And once I show this to you guys, I'm going to be moving on and hopefully making an actual finished part out of some different material. But let me show you where we're at with this, okay? So here's a few samples and actually some finished parts right here. This is what I am making right here. I'm calling it the clamping bolt for the Hardtail Vise, and it is, again, going to be replacing this guy right here, these, okay? Now, there is absolutely nothing wrong with this. This is a good, solid design. Jason over at Fireball Tools has done an excellent job engineering this vise and all the parts that he's put into it. So there's nothing wrong with a telescoping handle, okay? What I was trying to do, what I would like to do is continue making this vise right here a little more unique, a little bit more my own. This one is the Made in USA version. Jason has somebody in the USA casting these and building them, and these are going to be available hopefully pretty soon on the website, you know, where people can purchase these. But a while back, he sent me the castings for the USA made version so that I could machine it myself and put it together. And let me tell you, there's a lot of work that goes into machining these parts right there. Got a whole playlist on the channel if you guys haven't seen any of this, machining every one of these castings so that it fits together. But some extra things that I want to do to this vise is, for one, we're going to be making our own clamping bolts, these guys right here. The other things that I would like to do is we're going to be machining our own spindle, okay? We're going to just make our own spindle. That's going to be some really good manual machine work. It's going to be good manual and CNC work because I would like to replicate the meatball handle here on the end of the spindle, and I'd like to use the Miltronics to machine this part right here. But the Acme part of it, the thread, is going to be done in the manual lathe. So this is going to be replaced. We're going to be replacing this guy right here. This is the nut. All right, so we're going to have a new nut to match the new threads that we're going to be putting on that spindle there. So that's two big projects. And the other one was this guy right here. I want a hex head bolt on this that you can use a wrench to, you know, loosen and tighten. It's just personal preference, and that's what I'm going to be going with. All right, let's go ahead and jump into our machining project for this week. And we'll start with the prints here. So these are some prints that I designed in Fusion 360. I had a really good session with Kevin over at mechanicaladvantage.com, and he showed me this is some new techniques that I hadn't seen before, where you have your first page is like basically, you know, the part that you're making, item 1 and item 2, the part number, material. So the finished part, once I make my finished part, I'm planning on making mine out of stainless steel. We're going to be using 17.4 pre-hardened stainless steel. That's my personal preference. That's what I want to go on my USA Hardtail vise, is stainless. All right, we'll get into that kind of stuff later on, but for our prototype, we're going to be using steel. So there was the first page. There is the second print showing the specifics, mainly for the lathe work, okay, and what it'll look like. And this is metric. We got a metric thread, by the way, M16 by 2. And then we've got groove detail right there for the undercuts that I want to put in there. All right, and then this is just simply the washer that I want to go with it right here. All right, 1/4 inch thick, 16 millimeter bore, 1.5 inch OD, just using the same material that we're going to be using to machine these. All right, so there's our 3 prints right there on what we're going to be making. These are the prototypes that I've been working on, and the reason why I have so many is because it's actually difficult to just make one part over on the CNC. It's not difficult to make the part, but whenever you're trying to tweak your program, if you got to make changes on diameters, finishes, maybe something's cut in the wrong place, whatever it is, it's better to just go ahead and make another one, or have another piece that you can put in the machine and go ahead and just turn and mill another one. And that's what I've been doing. I've got some more over there, and once I got things dialed into where I want, it was real easy just to keep going and just keep making a few more parts so that I would have some extras to put in the machine and work on. So that's exactly what I'm doing. These were the first 2 that I machined right here. Now the threads on these guys I did over here in the Precision Matthews lathe. I did this manually. Turn it, I put the thread relief in there, threaded it. But I did something that I've always taught you guys. I did something that I've tried to correct other people in doing, is I went ahead and I took this bolt right here, the regular clamping bolt, and I don't have my calipers. Let me go grab them. All right, I had the calipers over on the machine. So what I was getting at was, whenever I took these out of the vise, I've always looked at that and just figured that's 5/8. You know, you can just look at it and kind of tell size. And when I measured it, let me show you. You're getting 621. Sometimes you get 620, just depending on where you measure it at. And I took that and I said, okay, that's 5/8. And that's all I did. I've always taught you guys to verify your thread pitch using a thread pitch gauge right here, okay? I never did that. I assumed that was 5/8. I went ahead and turned my very first one. Actually, I turned 2 of them. Turned and threaded for 5/8 11 UNC. Beautiful threads, right on size. We got a 5/8 flange nut right there, you can see. Goes on there nice. and I never could get it to screw in to the nuts over on the vise. And after a couple tries, and even chasing the thread and taking a couple thou off the pitch diameter, still wouldn't go. I said, I think I know what's going on. And I went ahead and I grabbed the thread pitch gauge on the 11, and it doesn't fit. So what does that tell you? You have a metric thread. So 2.0 fits on there right. So I made a mistake and turned these 5/8 when they should have been turned 16/2. All right, so another learning lesson right there. I've told you guys plenty of times, always verify your thread pitch whenever you're machining these on a lathe before you make a part. Now this is no big deal for me because this is just a prototype, a sample part. But if you did this to a customer part, then you're eating your labor and material costs and all that kind of stuff. So just prevent that by having these inexpensive tools in your toolbox and verifying your thread pitch. All right, there's today's lesson anyway. All right, so these guys right here are, you know, just trinkets now, little knickknacks that go on the shelf, right? Here I have 2 finished prototypes of what we're going to be making. I even have the washers here. Nice close tolerance fit. We have my logo engraved on the face right there. We're going to have some good detailed video showing this being machined, so don't worry. I've got my iPhone that I try to get in there and get detailed videos of this kind of stuff, and we will be sharing that with you. All right, so this is what we're going to be making right there. This is an example of the material, 1 3/4. I'm almost positive, I don't know for a fact, but this material, this was given to me by a friend. He had a bunch of it and just give it to me. I believe it's 1018 cold rolled, so it's softer, it's gummy. This is not material that you want to use to make a bolt with, but if you're making a sample part, there's nothing wrong with it. So that's kind of what it looks like right there. When I first started, I was turning them, threading them, taking them out of the lathe, cutting them off in the bandsaw, just like this right here. And then I just continued to refine it. I said, well, let's see if we can just use our parting tool in the lathe and turn them, thread them, and part them off. So that's what I'm doing now. And this is the first time I've done this. You part it down to a small diameter and then in the program, and then you come in there and you just wiggle it and break it off. I finally got it figured out to a good size where the first 2, it actually broke it off before the program stopped. So I've got it to where it leaves, it's 150 thousandths on the diameter, 75 per side. I also added the corner radius down in here. I didn't have the tool that I needed for the CNC lathe, so I went ahead and got one from Walter, and it's a 2 millimeter wide full nose radius insert. So I was able to modify it. You can see this one right here does not have the corner radius down in there. So I made several of them without the corner radius, and then once I got that tool installed, I was able to add that to the program and get it proven so that we didn't run into this face right here and cut that little undercut on there as well. All right, so that's where we're at. And then once it's turned into this part right here, then I go to the CNC mill, drop it in our 3-jaw chuck, and I've got a program where it's going to machine the hex. It's going to deck the top of it, chamfer it, engrave my logo, and it's pretty much a finished part at that point right there. All right, so I think that about covers everything. I will go ahead and we'll screw one of these in so you kind of can see what this looks like compared to the factory handle. And then let's go, I'd like to cut a couple more of these guys and show you how the program is working on the CNC machines. All right, want to show you what these are going to look like. So we're on our hardtail, and just so everyone's aware, this is the made in Taiwan version of the Hardtail Vise, okay? Where that one is the made in USA castings that we've been working on. So if you guys buy one, this is what you're going to get right now, okay? And absolutely nothing wrong with anything on this vise right here. Fireball Tools has some excellent videos on their YouTube and their website showing the torture test that they put this vise through compared to other well-known vices like Wilton, Reed, and all the other popular ones out there, and how well these guys perform under the stress loads. All right, so here is the original handle. Takes a little bit to unscrew it. Let's go ahead and pull this one out. All right, that one out. And we take one of our samples. Just like that right there. See, I went with stainless steel bolts, and I wanted this to be stainless steel as well, just to give it a really interesting contrast. I personally like it. It's just a personal preference, guys. Just like these bolts here on mine, the USA version, these are stainless back here. But that's it. That is what I'm going for right there. I like it. I think it looks good, and this is what we're gonna have on our USA casting right there. So let's go to the machines. We're gonna start with the lathe work, and then we'll get those turned, and then we'll go to the milling machine and mill the hex. This is that material that I've been using to make the sample parts, just some cold rolled 1018 steel that my friend Blake gave me a bunch of this stuff. So I'm gonna go ahead and take this and just cut it in half so it's not as long, and we'll be using this to make some more sample parts there. All right, we're ready to go into the ML16 with our stock, and got all the tools loaded up. Everything is on size. I've got everything working really well, and we're gonna be using our tailstock for this job there as well. I didn't want to do any turning and threading on that 5/8, or I'm sorry, the 16 millimeter shank on there without any kind of support. It's just too much stick out there, and I think we need the support of the live center. So as I mentioned, going in here and doing this work over and over again, repetitive, is continuing to teach me and improve how to use these machines and what I need to do. You know, for example, the tailstock, you know, I've got this really nice extended nose live center, and I've got the quill almost all the way out, 5.5 inches, and that's what it takes to clear this carriage and make sure that our tools and everything clear there as well. So let's get this loaded up and start making some chips. Bandsaw cut side, I want to make sure I started with that. All right, so to get my Z0 position, I'm using my Starrett small combination square. I've got it set to where I need to, and I just come up here and do this with the stock and get it just where it's nicely butted up to the square and the first face of that jaw right here. And once I have that, I tighten it up and it's where it needs to be, and it'll face off 10 to 15 thousandths, just depending on how far out that is from where I tighten it up at. I usually just do another check with it, and I can tell that you got a few thousandths clearance between the rule and the jaw, so it's going to take probably 15 thousandths off that face right there to start. We'll start you out with the wide angle there. I will get in here to get you some better detailed shots of the cut, but let's just start here. So we're going to, order of operations, face it, center drill it. We'll stop the program. I'm going to bring the tailstock up to support it, and then we'll continue on the program. It'll be rough turned, it'll be finish turned. I have two separate grooving tools to put the thread relief undercut and then the shoulder undercut in there. Two separate tools to do that. And then thread it, and the last thing is the parting tool to part it off. And then once it parts it down to the small nub, we'll come in here, we'll move the tailstock, reach in here and break it off, okay? Close the guard, and we are ready to hit cycle start. I usually bring it in nice and slow just to make sure that I am in the right Z position. Face it. All right, I got an optional stop going. It's going to be our center drill. I'm using a PEX cycle on that center drill just to kind of take it nice and easy. Make sure it doesn't come in there and just snap the tip of that center drill off. All right, and so this is where what I've got to do is I'm going to go cycle start to go to the next. It's going to bring our turning tool back up. What I've got to do is I've got to let it do the tool change and then bring this carriage back up to where it needs to start cutting before I can bring the tailstock in. Otherwise, this is too far back. So I just bring it in nice and slow. And then right there, where it's going to come in to start cutting, I stop the spindle. All right, stop the spindle, and then I'm going to reach back here. I've got it pushed way back. Let me come around here, and I got to come from the back side. Push this forward. All right, this is the kind of stuff that all made me super nervous going into this job. When you're cutting down to a small diameter like that, I keep feeling like this right here, this is all going to hit. But I've learned that there is clearance here. It's not going to hit the tool turret. All right, so we come up here. All right, lock it in the back. And I don't put a ton of pressure on this. Matter of fact, I back off and I just run it in with the hand wheel just until it touches, lock it, and now we're ready to continue on. So all I have to do at this point is just turn on the spindle again, forward direction, turn back on the coolant, and then the rapid button, I've got it down on 0. We're going to go up to 100%. Now it's going to start roughing it in. So I do have the max RPM for the turning set at 3,000 RPM. I'm not comfortable spinning this thing up super fast, so I kind of limit it to 3,000. When I'm doing the grooving, I've got it set to 1,000 RPM. These chips are flying back here hitting me. And when I'm doing this roughing here, a lot of times I come up here, you can see our 3D image of it. I've been going up an extra 10% on the feed while it's just roughing that in. Slinging chips at me. And we got it maxed out at 3,000 RPM. All right, now that we're down underneath that 1-inch diameter, we'll bring this back down to the 100%. That's the last roughing pass. It's going to make one more roughing pass actually. Cut that chamfer and take the last few thou off of it. All right, here's your finish pass. Just taking 10,000ths off of that, all of the diameters here, 5,000ths off of the shoulder face. All right, cycle start. Now we're going to be going to our groove. So the first one is going to be the undercut for the threads. Rough it out, finish it, chamfer both corners. Just that quick and easy, all right? That is a 3/32 wide full radius tool. The Walter MX22 is the tool. All right, the next one, we're gonna be going to that new 2mm wide grooving tool so we can get into that shoulder. All right, I'm gonna slow this down 50%. You see that movement right there? That's what you have to sneak up on and get comfortable with it doing. Otherwise, you think it's just gonna crash and wreck and tear the machine up and tear your tools up, but it works. We've got a beautiful undercut in that corner right there. Wow. All right, so cycle start. This is our thread. 16x2. I think I've got it set at 7 or 8 passes. It's 4. 7. And a spring pass. Okay, I believe it's 7 passes and a spring pass. All right, I'm just gonna go ahead and I'm just going to hit stop and just look at everything real quick. Everything looks really good. Let me get you in there so you can see that. Like I said, that 2mm wide grooving tool to get to that shoulder, I had to play with it because it was trying to hit the face. It was trying to cut the face. We made some changes to the program so that it didn't come straight in that way. It actually comes in from the side and comes in there and cuts that out, and actually cuts a little bit of a chamfer on that too. So it was cool modifying it to get to just every little thing you can do to improve that is wonderful. All right, so last thing we're going to do is do the parting tool, and hopefully it's going to work out the way I told you that it would. So let's start spindle, cycle start. We're going to this is our Tungaloy parting tool. I've got it going with a sort of a peck cycle also. It goes in 100 thousandths, breaks the chip, and then continues on. It just keeps doing that. All right, and then that's it. So that's the end of the cycle right there. Everything looks good. We can go ahead and loosen our tailstock, slide this back out of the way. Now we come in here and break this off. Go ahead and do that. This is a safety switch too, by the way. So if that guard is open, there's a switch back there and it won't let the machine operate. So just a good safety feature. All right, there you can see we've got it parted. So we take our, oh, you know what I forgot to do? I'm coming in here, I'm actually running the mill smooth file over the top of that just to remove any of these sharp edges. Let's do that before we break that off. I was getting ahead of myself. I just want to make sure that I don't bend it with the file, so that's why we're putting this in there. All right, and then we start spindle. Oh, see, there's the guard. Got to close that, spindle on. And I just got a mill smooth file right here, and I'm just lightly just taking the burrs off of it, okay? That's all I'm doing. The burr on the very end of the thread right there, down in the undercut, and that's it. Stop the spindle, feel it, it feels good. All right, now we're ready to go ahead and break it off there. So I'm gonna move the tailstock back again. All right, I think you guys can see that just fine. Just take it and there it is. All right, and then even this little nub isn't going to give us an issue because that's all going to be milled off over in the milling machine. So there we go. There's 1/2 of it machined. All right, let's cut one more. I'm going to try to get a little bit better video for you this time. Go ahead and loosen this up. I found that this pinion right here is in a good position for me to loosen up. Grab the combination square here and just try to get it close. Like that. Snug it, and then I check it just to be sure. That looks good right there. And then we'll retorque it. Close the guard, and we are ready to machine. All right, face it off. And we're going to go to our center drill. All right, we need to go ahead and this is where we need to bring our turning tool around and bring it up to where we're going to start cutting. Right there. Bring it down to 0 to stop it. Stop spindle. And now I'm just going to bring our tailstock in. Okay, our tailstock is in. We are ready to turn. First thing we'll do is just start spindle. and then bring our rapid up. It's slinging chips straight out this way, and they're like little hornets that hit you, so it's hard to get in here by hand to hold this. Ready for a tool change and then go on to the grooves. All right, so for the next couple ops, I think I'm going to disengage the coolant so we can get in there and show you guys a little bit better detail of what it looks like. I'm also going to slow it down so you can see the movement of the tool. All right, so let me go ahead and drop that down. Cycle start. Turn the coolant off. Let me slow this down. I'll tell you what. So this is an adaptive grooving tool path that Kevin taught me about. It just takes, it basically comes in and it goes like that. Whatever depth you have it set at, I think I have mine set at 15 thousandths per pass. Cut the groove, make a finish, and then it's going to chamfer it. Chamfer. All right. Now we're going to swap to our 2mm wide grooving tool. This one I'm going to slow down as well so you can see the approach. Up. Coolant off. That groove cycle is, it's going straight in, but it's like a peck. And it's going to chamfer the corner right here. Just break that corner off. Isn't that sweet? All right, next up, we're going to thread it. Disengage the coolant there. I apologize if this is not focusing. I am trying to get it to focus. This doesn't seem to want to do it. That was our finish pass there, okay? All right, last up is our parting tool. So this one I will use coolant. Now I'll file the threads off, move that back, and then we'll break it off. There it is. See if we can see that a little bit nicer right here. I've made many changes on the program to try to improve every bit of this, from having a larger chamfer here on the end for the thread, better finish it on the thread, breaking the corners for the grooves right there, and even on that shoulder, that little undercut in the shoulder, it was leaving up a sharp burr there, and I was able to add a small little chamfer pass to that to break that edge off, to eliminate having to do it manually or reaching there with a file or something like that. But there we go. Now we are ready to take this to the CNC mill to finish it. All right, this is our setup for the milling machine. These are the two that we just turned, that you just saw me turn. These are some that I've already done previously that I was working on the last couple of days. This one is one that's left where I actually, after I added the shoulder radius in there, the 2 millimeter wide groove, these two are what's left of before I added that shoulder groove in there. You can see there's a burr hanging off that thread. That's another reason why I was reaching in there and filing it, just to kind of knock any of those burrs off while it's still in the lathe there. And these are some that we've already got milled and finished. You can see there's not a corner radius down in that bottom, and then these do. There's one that you can see how I touched the face with the grooving tool there. So it's little tweaks like that that I'm always having to, you know, if you do that and you mess a part up, it means you got to make another one, right? So that's why I make so many of them, because I make one and I make an adjustment as needed and then make another one. But it's, you know, it's just good. The material that I'm using was free, and this has given me lots of training and practice, and it just helps me out. That one looks really nice right there. All right, so let's go ahead and we'll get one loaded up and start our milling. Okay, into the mill we go. So the top of this jaw is my Z0. So in the program, this face right here, we're working the top side of that. So I just drop it in. I make sure the chips are off of it. Just drop it in, snug the 3 jaw up. It doesn't have to be super tight. I take the soft blow and I give it one good tap like that, and now we are ready to machine. So the way this is going to work, we're going to be using this 1/2-inch 4-flute Walter end mill to come in. It's going to do an adaptive tool path. It's going to make one round cutting some material off, and then it's going to come and machine the hex off using the adaptive, and then we're going to have a finish pass around there. It'll actually take 2 passes around there, and that was what I needed to do to get it on exactly the 1 1/8" hex is what I was going for on this right there. So a nice finish path is leaving a beautiful finish on that hex there. All right, so once it does the finish pass, we will have I ended up going with, I've got my Tungaloy Tongue Force Rec 1/2-inch insert mill. We're going to use that to deck the top off, and the reason why I ended up using that is because it's leaving a little bit nicer finish versus the finish on the end mill there. Just a little bit smoother, a little bit brighter, and I really enjoyed that. So after we mill the top, we'll use a chamfer tool. I got a 1/4-inch chamfer mill that'll cut the chamfer on it, and then I have a engraving tool. It's a single flute engraving tool in there somewhere. Actually, it's in the spindle, my bad. And it'll come down and engrave my logo on the top face there. All right, let's get going. We'll start off with a nice wide shot so we can kind of discuss things and see what's happening as we do it. Cycle start. We'll do a tool change to tool number 4, which is going to be our 4-flute 1/2-inch end mill. Going to go around it. We got some really nice graphics up here so you can see what's happening. Cut it round, Then it's going to come back and do the adaptive for the hex. This is going to be the finish pass here. All right, what I've been doing, see those chips build up? I've been turning the air on. It's helping to blow those out of the way. See that? It's basically just making a spring pass there. All right, we're going to do a tool change to our tongue force rec end mill. There you go, that guy right there, 1/2 inch diameter, 3 inserts. That's it, it's finished. Let's see if you guys can see this. I'm just gonna stop the spindle there before we continue on. Just got a beautiful finish on the top of that using that end mill there. After this one, I'll get you some tighter shots with my other camera. 1/4 inch diameter chamfer mill. Got a 10 thou chamfer on the top. All right, and then now we're going to go to our engraving tool. That's this guy right there. Running 8,000 RPM, which is maxed out on the TRM. I am going to be running air with that. And this is our classic 8-bomb 79 logo that's going on the top face there. I've got that tool set 2 thousandths deep. And I think it's doing a great job. I like the finish with this engraving tool versus the finish I was getting with the center drill, just because it's so much smaller, a little bit finer detail on something small like this. You can kind of see it on the graphic stuff here. Let's see if we can tilt this down a little bit. It's just really hard to see, but one of the chamfer tool isn't defined very well. That's why it kind of looks a little goofy on the graphics there. Should be just about towards the end. All right, there it is right there. There it is. I love it. Beautiful. I'm excited to see what these machine finishes are going to look like on something better, like our stainless steel, or maybe even a piece of 4140. But I think that looks great right there. So just like on the lathe, you know, it took several of these to get this right. I would make a finish on there. I didn't like it. On some of them, all I would do is just bring the Z coordinate down about 5 thousandths and recut it until I was getting the consistency that I wanted with both the facing tool and the grooving tool there. And I've got it to where I think it looks really good. So we'll go ahead and take it out. And that is a finished part, with the exception of one chamfer that we still need to put on it. That's this guy right here. I just do not have a tool. I don't have the proper tool here that I need to be able to get down there and chamfer that edge. So that might be something that we improve on later. But for now, I'm just going to put this in the manual lathe, and I'll have a tool and come up and just knock that edge off about 10 thousandths. But there we go. So we've got, this is the other one that we just turned. So we'll go ahead and get the chips wiped off of here, get it loaded up, get it machined, and see if I can get you some better footage of the next one. We are loaded and ready to start. finish. A little better look at that finish up there. All right, well, there it is. Is it gonna focus? What do you guys think? So one thing that, you know, anytime you're taking, I hate how that camera does that. It tries to jump from like one thing to another, and I wish it wouldn't do that. But one thing that I've learned a long time ago is that the pictures and the videos on a freshly machined surface like that can really kind of skew it and make it look worse than it really is. I mean, because that's actually a beautiful finish on there, but it, you know, some people may look at that and say, I don't think so, but it really is. That is a nice finish on there. It's got a nice slick, smooth feel to it, and I liked our depth in the engraving. Worked out good. All right, so these are the two that we just machined right here. You can barely see the chuck marks on there, but that is on there. So as I said, we do need to come and cut a chamfer on that edge right there, and we'll do that last. But I really like that. I think the tongue force rec is leaving a nice finish on there, and our engraving tool is doing a really good job. Here's the second one right here. Well, there we have it. Remember, these are being machined out of some 1018 steel, soft gummy steel. So it's going to be nice to actually machine in some good hardened material and see how much better we can get these to look. All right. There's those two there. So I still have some of these others that haven't been machined yet. So I think I'd like to go ahead and put one more in there and see if we can get one more good cycle of videos of the machining of the hex on one, okay? All right, now that we've got all the CNC machining done, we're set up on the manual lathe here just for this last stop of breaking this corner off. I got a 10,000 chamfer I'd like to put on that. So this is my setup right here. We're using the CNMG tool. We're using the 100-degree angle on there, or the 100-degree corner, should I say. Pretty simple. And I got a dial indicator down here set to a 0 where it first touches. So just bring it into the face, clamp it lightly, and we'll turn it on. Tools shouldn't hit tip of the tool anyway. I was trying to get as far as I could. All right, and then got this indicator down here. Once it touches that edge, it should be right there on 0. So bring it up, and should be right there on it. And I just go another 10 or 12 thou, just like that. Don't move the cross slide, just bring it back. Careful taking it out, and then there's your corner break on it. Simple as that. So I got the 3 that you just saw me machine, and I got 2 more over here that I haven't chamfered yet, so we'll do 5 of them. I have the DRO set to a 0 in our X, so it shouldn't hit. So once you get in a rhythm here, if you got several of them, you can just bring it on up, chamfer it, move it back. I would like to see if I can get this going in the CNC. I'm sure it's easily done. The pros that know how to do that stuff already probably have plenty of solutions for that, but this was just the simplest thing for me to do. Indicator sticking. All right, last one in this little batch. All right, all of them chamfered equally. And we now have a finished part. So these are the 3 that you saw me machine in today's video. These guys right here. And there's one more component that I still have to make for these. I've already got a couple made, but the washer, let me get to that print right there. So this right here, you know, we still need to machine some of those. I haven't even done a program for this one yet. The first 2 that I made, I just did it manually over there on the manual lathe. But I would like to work on writing a simple program to be able to do this over on the CNC lathe there as well. You know, get them face drilled, parted off, and then probably set them back up for a second op to face off the other side nice and clean. But that'll be a separate video project, whatever. I've already got 2 of them made, as I said. These 2 right here. Got nice finishes on them. Got both sides faced off, 1/4 inch thick, matches the OD. So we'll take a couple of these that we just machined and go ahead and put them on there. There we go. How about we go put them in the Hardtail Vise and see what they're going to look like. We'll go in the finished Hardtail Vise right here so you guys can see what they're going to look like, because this is what I was talking about earlier, as in some things that I might consider machining or making and selling to some other people. So once I get this program figured out and you know, get the material that we're going to use to finish this, I'm going to use stainless for mine. We may end up making, you know, some pairs of these to sell to others if there's any interest in this right here. You know, maybe consider a small batch of them or something like that. But see, I like that. This is the look that I was going for right there. I've got the stainless steel bolts holding it down to the table, and I wanted these stainless steel as well on my vise. So I'm liking that. Now the only issue with the engraving on there is that you just never know where the orientation is going to end up after you get it on there, but really no big deal. At least it's got my, you know, my logo in there. Let's put one in the other side. Yeah, this one, the orientation is kind of upside down, but no big deal. I like it. So for my personal use, you know, I made these 1/8". Just got to have an 1/8" or wrench, you know, 1/8" wrench or socket to be able to come over here to these guys and use the wrench to tighten them up just like that. Got a good fit on the wrench, or you can use an adjustable wrench, you know, whatever you want. Let me grab one of those. Take an adjustable wrench and use that to tighten them down there as well. So that is the look that I'm going for on my Hardtail vise. I'm liking it. Let's go ahead and screw them into the USA Hardtail as well and see what they look like. I know it's not finished, but I haven't put them in there yet. I haven't put one in there yet, so I want to see what it's going to look like over on the raw casting. All right, here's our USA Hardtail vise. First time going in with these guys. We have our freshly machined pads there for them to bolt down to. I like it. I like the look. So what do you guys think? You dig it, or would you rather have the original handle on there? I think it's just down to personal preference. I know that this is much more convenient. If you're in a fast-paced shop, you know, a working shop where you're using a vise constantly all day, you may not want a wrench on there to loosen this up. You may just want to keep that on there. But for me, for our special edition hardtail vise, the USA version, we're going to be going with these machined from A-Bomb 79. Only they're going to be 17/4 stainless steel. But I'm liking it. Really do like that look. So real happy with the outcome on this. It's really coming together and looking nice. And I'm excited to see the finished result once we get all this stuff finished. We still got to make our custom spindle, make our custom nut for it. And once we get those done, I think the machining and building of it will be about complete. From that point, it'll be whatever kind of finish we're going to put on there. And I still haven't even decided that yet. But really loving these guys right here. So something that I wanted to mention was, so I've got a bunch of these samples right here, you know. I'm going to have one or two probably that I'm keeping and putting on my table in there for my little, I don't know, just my little knick-knack table, stuff that I've made. But I've got about another 8 or 10 of these over there that I still need to machine, including these guys. I thought that it might be nice to offer up some of these extras to anybody out there that's interested in them. I've been kind of playing it through my mind on getting my eBay store set up and practice there. You know, I've never really sold anything online before, just sort of, you know, marketplace and messaging. But I thought about giving it a trial run to see how it works for me, putting these up on eBay and putting them up for sale. I don't know, I don't even know what I need to charge for them yet. I still got to work that out. But these would just be, they're just trinkets, really all they are. I would not recommend using these in a vise to tighten it down. It's really just a sample. It's a prototype part that's not to be intended to be used because it's made out of 1018 cold rolled. But I know that there's some people that ask about this kind of stuff. I have people that message me, you know, and try to reach out for that kind of stuff. So I think I'll have a batch of these that I'm going to put on eBay at some point, hopefully very soon, and offer them up for sale. What I would like is, let me know in the comments, are you interested in these, you know, a sample piece? And also, if you have a hardtail vise, would you be interested in a set of these guys right here for your own vise? Not machined out of the soft steel, but it's probably either going to be a 17/4 stainless or possibly 4140. I just haven't decided yet. I'm putting a feeler out there. I want to know what you guys think, if there's any interest in these and buying a pair of them. And if so, we may go forward and see about making a small batch of them for some of you other hardtail vise owners out there, okay? All right, guys. Well, I think that's going to wrap up this week's Saturday night special video. I hope you had fun. I hope you enjoyed watching the video and the footage that I shared with you on the development, the prototyping of these clamping bolts for the Hardtail Vise. I really like the way those look, and that I know that's a personal preference, but that is what I was going for right there. I'm sure there's all kind of cool ways you can do that to make it, you know, customizable for your own. You can even drill a hole in there if you wanted to you know, put a handle in it like this right here. But I didn't want that. I didn't want any extra features in there, just being able to come over here with a wrench to be able to tighten them up and loosen them. And I believe I spoke on this before. I can't remember now, but this vise right here is a very special piece for me. I have no intentions on putting it through any kind of hard work in any of my shops. It just really means a lot to me that, you know, Jason was so kind and wanted to work with me and collaborate with me on building a USA Hardtail vise there. So this is just a special vise that I've enjoyed machining, building, customizing. We're going to continue to customize it. Hopefully we're going to have a cool paint job on it one day. And this is just going to be like a showpiece for the shop, just a centerpiece. It's not going to go through any kind of hard, heavy work. That's what we have. This one right here and other vices that I already own, you know, we'll use those for our heavy duty work that we're going to be using. But anyway, like I said, if you guys have interest in a pair of these, let me know in the comments. I'm trying to get a feel for it. If it's you know, worth the effort to go through and make a small batch of these and put them out there for sale, which would be probably my first product that I make and sell to others out there, and you know, for other hardtail vise owners anyway. So let me know what you think about that. We'll go through the comments and see what kind of feedback that we're getting on a custom flange bolt for the Hardtail Vise. But anyway, that's going to wrap this up. I wanted to give you guys the updates on the Flex CNC, you know, the ongoings with the Miltronics, and everything's going really good. I'm looking forward to another good year here in the shop, and I look forward to seeing you on the next video. Remember, we got some repair projects coming up. We've got a hydraulic cylinder we got to repair, and we've got that piece of tubing down there. We got the machine, and I got other stuff in the works too, you know, so we'll keep the content coming, and we'll see you next time.